defined by an oxygen bounded to 2 carbons. The functional group of ethers can conform to many different functions, making an important character in synthetic transformations. Ethers have a pair of alkyl or aromatic groups attached to a linking oxygen atom. Ethers are surprisingly unreactive and are very useful as solvents for many but not all classes of reaction.
Today, I will be discussing 5 properties of ether. Number 1, an ether molecule has a net dipole moment due to the polarity of CO bonds. Number 2, the boiling point of ethers is comparable to the alkanes but much lower than that of alcohols of comparable molecular mass despite the polarity of the CO bond. The miscibility of ethers with water resembles those of alcohols. Number 3, ether molecules are miscible in water. This is attributed to the fact that, like alcohols, the oxygen atom of ether can also form hydrogen bonds with water molecules. Number 4, halogenation of ethers. Aromatic ethers undergo halogenation. For example, bromination upon the addition, halogen in the presence or absence of a catalyst. And the last one, Friedel-Crafts reaction of ethers. Aromatic ethers undergo Friedel-Crafts reaction. For example, addition of alkyl or acyl group upon the reaction with alkyl or acyl halide in the presence of a Lewis acid as catalyst.
To identify ethers, in the carbon chain, it was separated by an oxygen atom in the middle. In the left and right carbon chains, name it as different substituents. Only rule in naming ethers is that you should place them in alphabetical order, and there are special prefixes if ever 2 carbon chains has the same number of carbon atoms. And then add the word ether in the end.
This is an example of an ether. In order to name a molecule, first we have to identify if it is an ether or not. In order to do this, we have to first look if there is an oxygen atom linked between 2 carbon chains. So in this example, it is called a cyclopentyl methyl. This is because there are 5 carbon atoms linked together in an enclosed chain. And if the chain is enclosed, you have to put cyclo in the first part of the name. And then you add pentyl because the name for 5 number of atoms is penta. So cyclopentyl. And then the methyl comes because in this cyclopentyl, there is a methyl branch attached to the oxygen. One branch is equal to methyl. So the name of the atom is a cyclopentyl methyl ether. In this example, it is called a cyclohexyl ethyl ether. Let me explain why. In the first name, it is a cyclohexyl, and this is because there are 6 carbon atoms linked together to form one enclosed chain. And like I said with the first example, if the chain is enclosed, then you have to put a cyclo in the first part. So it is a cyclohexyl. And it is a hexyl because there are 6 carbon atoms. Unlike the first example where there are only 5. The second name has the word ethyl in it, and this is because there are 2 carbon atoms linked together with the oxygen atom. And unlike the first example, instead of a methyl, we call it ethyl because there are 2 carbon atoms. So the name is cyclohexyl ethyl. And lastly, don't forget to put the ether at the end. So the name of this molecule is a cyclohexyl ethyl ether. This example is called an isopropyl methyl ether. Let me explain why. The first name is called an isopropyl because it is one of the 4 special substituent branches of naming molecular formulas. The next name is a methyl. It is because there is 1 branch of carbon atom attached to the oxygen atom. And lastly, put an ether at the end of the name. So you have isopropyl methyl ether. This example is called butyl ethyl ether. Let me explain why. First off, the first chain is called the butyl. This is because there are 4 carbon atoms linked together. attached to the oxygen atom. And the next one is ethyl. This is because there are 2 carbon atoms forming a chain attached to the oxygen atom. And like we said, it should be named in alphabetical order. So B and E. So this forms butyl, ethyl, and then at the last part of the name, you have to put ether. So the name of this molecule is butyl ethyl ether. This example is called a diethyl ether. Let me explain why. First off, the first branch attached to the oxygen atom has 2 carbon atoms, and as we learned, you call that an ethyl. And there is another 2 carbon atom attached to the other side of the oxygen atom. So basically, there are 2 ethyls attached to this oxygen atom. And in order to name that, you have to put a di and the first name of the ethyl in order to signify that there are 2 of them. So the name is diethyl. And lastly, don't forget to put the ether at the end of the name. So you have diethyl ether.
Our next example is diisopropyl ether. Now, the oxygen atom separates 2 isopropyl chains. And this is why it is called diisopropyl ether. Di for 2. Our next example is cyclobutyl propyl ether. Now, cyclobutyl is a closed carbon chain composed of 4 carbon atoms. And on the other side of the oxygen atom, we have propyl, which is a 3 carbon chain atom. So that makes cyclobutyl propyl ether. Our last example is secbutyl cyclopropyl ether. Secbutyl. And on the other side of the oxygen atom, we have cyclopropyl, which is a closed carbon chain consisting of 3 carbon atoms.
Did you know ether was known as sweet vitriol until 1730? Ether was discovered in 1275 by a Spanish chemist named Raymundus Lullius, while ethyl ether was first created in a laboratory in 1540 by a German scientist named Valerius Curtius. In the present, ethyl ether, a volatile, colorless, and odoriferous compound, is often used as a solvent for certain oils, rubber, and other fatty compounds. Ether is also utilized along with other anesthetics to produce a state known as balanced anesthesia. This combination is used due to the slow rate at which ether causes unconsciousness in patients. If administered at high concentrations, respiratory arrest can occur. More minor symptoms from ether exposure includes dizziness, nasal irritation, and the drying of skin. The molecular formula of ethyl ether is CH3CH2O.